and understanding the platform, the architecture, the OS features, and focus. And now we focus on iOS as well as Android platforms. Today we are going to talk about understanding of app and security controls around the application. Okay, Mitesh is back again. Hey, Mitesh, can you talk?
Maybe you can just drop off and rejoin, Mitesh.
Okay, all right. So Mohan, would you like to talk about?
So, so in this three-part series, what we initially we started with, like one session, but then we realized that this is quite a big task, because there are multiple areas, and it is better to give some justice to each of these areas than just go through it quickly in a just touch and go kind of fashion, right? And that's the reason we split this in three-part series. For in the last session, we covered mobile device security, where we looked at what are the different components in that device management. So we looked at mobile device management, and we saw the different layers, right? One, hardware, the underlying hardware, then the firmware given by the manufacturer, then the mobile OS sitting on top of that firmware. It could be iOS, Android, or any. So we, since there are multiple OSs, we just focus for the sake of convenience, iOS and Android, because these are widely used OS devices. And then on top of the mobile OS lies the application, right? And then that basically the entire bundle is basically part of the mobile device management, right? So we covered that in the entire session in the last meeting. So Mitesh touched upon these two URLs in the last, and these two are applicable even today's session, right? So today we're going to focus on mobile application security. So we looked at mobile device security. Now we are looking at mobile application security, and the next session will be on the APIs security. Because slowly what we have seen is the world is moving towards from desktop applications to mobile applications, and the whole of the organization's portfolio of application is now getting switched to mobile, and this has been happening since I think more than a decade now. Some have picked up quickly, some are a little slow. So we'll touch upon basically if I am coming from, say, in general, I'm an IT or developer, or I'm in IT operations, or I am coming from a hardware, which was the case for me, basically hardware, firmware, and then we will move into how these different variety of people can actually get into mobile application security. So since we have still some time, Mitesh is yet to join, let me talk about how my journey started. So I was working for a startup called Manipal.net at Manipal in India, and this startup actually, the project on which I was working on in the startup was related to semiconductors, basically, which means the customer used to give us one line requirement, and we had to come with complete specification of that chip, or it's called FPGA, field programmable gate arrays. And once we come up with that, we have to ensure that the chip works in the way in which it is expected to work. And so that part was on development board, right? And that development board, we used to configure it through open source technologies like Linux and Android, right? Because that's a low cost or zero cost rather. But we had to learn all those integrities about how to manage the open source details like kernel, the OS layer, in that the application layer, then the user layer, etc. Right? And then, so I was very well versed with Android. I in fact ported the kernel, ported the device drivers, and then I moved to Android application security ecosystem. Because I knew underlying hardware, underlying firmware, as well as mobile OS, it was very smooth transition for me to secure OS into OS level details or whatever knowledge that I had from the lower layers into extend it to application security. Because when you're changing a driver, when you're changing a kernel, you have to think a lot. I remember I had given a presentation where I said, it's a triangle. A normal developer develops like say 1,000 lines of code in a day, supposedly 100 lines of code at device driver level gets written in a day, and then only 10 lines get written in the kernel level. So that's how complex it is. So you have to think from all different angles as you go in the mobile OS as well as downward towards the firmware. So I came from that background, and yeah, that's how I moved into mobile application security, and then I got into web infrastructure and so on. Now that we have Mitesh, yeah, Mitesh, over to you.
Thank you for sharing your journey. Thank you, very interesting. Hey, Mitesh.
Can you hear me?
Yes, we can. Right. Yes, we can.
Go ahead.
All right. So, Mohan, thanks for giving that down. The key message there is that we started with that device security, and now we are going into the app security. And this is where the very important concept comes into the picture, is where now you are going to bring in the data on the device, and that's where the security really kicks in, because without data, the device is just basically with an operating system, right? So what are the skill set that you need when you go into the app security space, or when you combine the data with the device, and what are the device and app security combination you need? So the last week's session, you will have to use it as a foundation, and now we are going to build on top of it. So when it comes to as a starting point, I think the very important thing that anyone who is coming in to understand is the iOS and Android app sandbox. How exactly the app is created when you actually deploy an app on a device, or download an app on a device. What exactly happens? What kind of file system structure gets created? Where that source code actually gets deployed? How it gets deployed? Is it just unzipping, or is it just a compiled code that gets deployed on the top of the operating system? And then the encryption of that data when the app brings in. So first you are going to add the app, and that's where the file system structure, where the data will be. If I need to encrypt it to protect that data, how that encryption, what are my options for encryption? And one of the most important concept in both the platform they have is called keychain or key store for Android, which is where the keys are actually protected. So how that works, right? What are the different levels of keys that each platform actually introduces as part of the device and the app security combination? So just like last time I suggested to learn the platform security guide as a starting point, when it comes to the app security, I would suggest this as a starting point to read and understand and build on the foundation of the device security.
Hey, Mitesh, I'll just bring up a question that had come in. And maybe it's a little bit early, but we are in the second session. So somebody has asked, they don't want their name revealed. So they've asked, how long will it take a developer to learn enough for a career in mobile security? So how long do you think? 6 months, maybe? If you can answer that.
Right. So it really goes to your motivation, right? Because I have seen people take the very expensive training, and then it comes with the certification voucher, and then a year later when I asked them, they said I still haven't used it. So it really goes to the motivation. But if assuming that you have a decent motivation, I would say 3 to 6 months is a decent time to come up to speed, because you have other responsibilities and your regular life as well. So that is probably a good ballpark.
Okay, that sounds extremely doable, right? So we're not talking about 4 year or something, career degree or something. So yeah, and obviously it is what you put in. More we're adding. Yep.
Specifically, if you're a mobile app developer already, then you have a significant foundation there, and you are now just adding the security feature knowledge on top of it, and you can be a really good security person at that point.
Correct, exactly. So I just want to compliment what Mitesh said. So if you're a developer, you're already 50% in the mobile app sec, by the way. Okay, you don't have to start from scratch. Like me, for example, when I started, it was quite a different journey because I came from device drivers, kernel, etc., and then moved to an application layer. But since you're a developer, you're already in there, right? So what you need to do is you could be a front end developer, you could be a back end developer. Maybe you could be a web developer or probably some kind of development that you are good at. Now, we will cover that anyway later on. So, what you need is basically, as Mitesh said, passion. How much passion you have towards entering into this domain, right? And since you're already in development, you can just start looking at. We'll give the references later in the slides, and then just go on learning. Because in this space, in general, in application security, what I have observed is, unlike in other disciplines of engineering, you get lot of support. Open source tools, open source, knowledge sharing, and then there are a lot of meetups like this and many more. So the people in this domain are actually so. I mean, they have taken so much from the community and learned and grown over a period of time. They want to come back and share it, right? So you get a lot of knowledge resources in the public domain. So it all completely depends on your motivation, your passion, and yeah, as rightly said by Mitesh, 3 to 6 months is just good enough if you are a developer. And at the end of the day, what you're doing as a developer, you would be doing some testing, right? Functional. Here we are saying that okay, you just extend the scope of functional testing into non-functional testing, right? So you may have heard of performance tests, you may have heard of security tests, and you may have heard of there are a few other areas in the non-functional testing. So you have to just extend the domain of what you're doing. Instead of functional testing, you just say, okay, how this can be exploited, how or what can go wrong in these scenarios, and then you can go further. Yeah. Anyway, we have more slides. We'll cover all that. Yeah.
So, Mohan, before we proceed, there's a question for you, and it says, Mohan, sir, it is nice to get your perspective as an OWASP leader. Does OWASP have a mobile device management project? This
Okay,
pertains to our last talk
yeah,
we had last week.
yeah. So as Mitesh said, he is not aware of any. In fact, I haven't come across with OWASP MDM project, but since OWASP is a volunteer-led organization, if there is enough demand for mobile device management, yes, there will be a project, and if you guys are interested, we can actually start a project. And once we see the momentum, we would get funding from different sources to continue that. So yeah, let us know if you're keen on joining that movement. Yeah, we can give it a shot at it. Yeah.
Okay, thanks.
All right. So moving further, when it comes to apps, right? So we talked about the file system structure. Now, the next thing I think the key is to understand what are the different type of apps in a real life, right? So you will come across, we all know about consumer apps. Go into public app store and we download them, use them every day. And that's where we interact with Apple App Store and Google Play Store. But when you are, and the key point there is that mobile app security is still the focus, but you will not be able to control the device because you don't know who is downloading that. You don't own the device. Therefore, you cannot just control the device, right? You cannot install an MDM on it or expect an MDM type control available on those devices. So everything that you need to do is it has to be inside the app, because there is nothing is provided as a service other than the platform features that are there for you to use. But if you don't use it, then nothing activated, right? So iOS and Android both offer you features as a developer to leverage, like encryption. But if you don't use it, then there is no control there. So that's the important point. If you're in an enterprise environment, as we mentioned last time, you will have a likely mobile device management type control. And this is where the use of mobile device management comes into picture, right? So we looked at the what it can do, but now what it is there for is basically mobile device management has two areas. One is it's controlling some of the features of the device that you can secure, but now it is also able to add value in the app security area. So it has really device and app security, both type of features built in there. And usually those apps are delivered through an enterprise app store. So every time you implement a mobile MDM type solution, it comes with its own app store that where the internal apps are hosted. So you're not putting those apps into the big app store. And wherever MDM is not available, there is also an alternate solution available where we call it mobile application management, which is really a subset of MDM. And it can be based on an SDK or app wrapping implementation, or there is an open source framework called AppConfig that can also be leveraged for mobile application management. So if you don't have a full featured MDM, something like AppConfig should be built into as an open source solution option. So
okay, I have a
mind and have a logical separation in your brain that, okay, when I'm dealing with a consumer app versus I'm dealing with an enterprise app, what is the controls I have available and as a service, and what I need to build into the app.
Okay, I have a question about what you just discussed about this mobile, like if you are an enterprise, then so would that MDM solution be able to onboard external apps? Would that work?
Yes, it can actually, you can take the third-party apps from the public app store and make it a managed app within your enterprise. That way, the data that goes into that app will actually be controlled by MDM, and you can actually have some oversight. You can apply policies on those apps. So yes, you can make it a managed app.
Yeah, I just want to share that so that people understand that you.
Right, and that is a very common use case actually. So
yes. Hey, Mohan joined. Mohan, do you want to add something to this? Okay.
All right. So we learned about the structure, we learned about the different type of apps. Now it comes to the core point, which is what are my security requirements, right? That is typically as a developer, you need to understand. And I have put some guidance document reference links here. The second link is actually a commercial vendor. So I just want to make sure it's not an endorsement of the vendor, but they just wrote that public article that is open and extremely useful. So just take an advantage of that, right? So starting with the NIST guidelines on how to vet your security application. So again, this you can reverse engineer this document and say, how do I convert them into the actionable requirement? That is, wherever they're saying that, okay, you should vet your applications this way, you can turn that into a requirement that, okay, going forward, I'll require this as to vet my applications, right? The second document gives you very actionable guidance, which is the mobile app security coding best practices, which is exactly what a developer is looking for. And then, as Mohan mentioned, there is actually a mobile top 10 project for OWASP. So you can get cheat sheet, you can get top 10 findings and requirement. You can start as little as there, but I strongly recommend that second link on the mobile secure coding best practices to be referred here. One other thing that, apart from those requirements, that developers, if you're a developer and going into the security, you need to keep in mind is the app permissions. Believe me or not, that is actually the single most important factor where the hacking attempts takes place, which is where app does not need certain permissions, but they just have an excessive permissions that are out there. And there are malwares, there is attacks that happen to leverage that channel. Because very little attention is being paid there because it's not a requirement for the functionality. So all the testing is happening without those permissions, and therefore they don't realize that there is excessive permissions out there. Second concept is unsafe APIs, which is basically unsafe in terms of security, right? So there are APIs exposed by both Apple and Google from their device as a platform. For example, leverage access to the camera, access to the microphone, access to their contacts. So yes, camera and microphone is more a functional requirement, but there is a variety of attacks has been delivered through those. And most importantly, unsafe APIs it comes into picture is where you have access to context, right? So context can be a significant. So that's where people are after is the bulk data, and how do I grab that? App signing is also, I'm sure as a developer you would know that, but within app signing, you definitely need to understand certain parameters like what is the key size that you need to use, what are the best practices for the signing processes. These are all important concepts that part of a time right now to go over, but I'm giving you pointers what you need to learn, go out. And there is so many articles out there, very easily you can find and that. Next is the services. So as a developer, when you develop the app, you're likely to leverage this services, which is basically push notification, right? One of the very common service that people use. If you are looking to leverage some of the controls that are available through platform, Android Safety Net for routing detection is an important one. And then in case of Android, one of the most easily can be attacked is the reverse engineering the binaries, which is basically they take the binary, they download it, the reverse engineer, and with a decompiler, you can actually get a source code back. So Android ProGuard comes into picture, which is basically it obfuscates the binary. So that makes it's not impossible, but it makes it difficult for people to reverse engineer. So these are like more becoming like best practices going forward. That if you are putting an Android app out there in the public app store, you should definitely use ProGuard because it's a feature available by Android platform and it obfuscates the binaries and makes it extremely difficult. So it allows you to protect some of the important logic that is built into the app itself.
Sure. I just wanted to point out that when we talk about app permissions, just the privacy factor, I know we are not like focused on that, but collect things that you don't want for your use just because, you can get the user because the user just wants to use it. Just don't collect what you can't protect. So just be mindful of you just getting enough data, but not more than what you need. Just because, you might push a feature and then at that point you might require it. There is an urge to, like say, oh yeah, let's get all these things and then we can drop them on the floor if we don't need them. But we might come up with a new feature and at that point, like going back and big a problem.
Right. To add to that, yes, in fact, if you have installed or if you're testing a mobile app and it is asking a lot of permissions that you think logically it doesn't require, that this app is actually trying to do something beyond what is actually been projected, right? So those are some of the cues that as a mobile app sec consultant, you can actually start digging into it, and then you would come out with some findings, So that's one. The second part is, if you're a developer, or if you're a mobile AppSec consultant and you have tested the native app. By the way, there are three types of mobile apps: native app, mobile web app, and hybrid apps. So native apps are developed by programming languages like Swift or Objective-C, for iOS. Then you have Java, Kotlin for Android. So if I'm talking about native apps here, mobile apps are basically apps that you can use or load or start or work with using mobile browser, mobile OS browsers. And then hybrid app is basically, it's combination of both. It starts from native and moves to mobile web, and so on. When you're testing such apps, right, first thing probably you can look at, as Mitesh already gave some background around what are the key areas that you need to look at: file system, and then all the mobile top 10, right, given by the OWASP. These are top risks that you should see, but there are a lot of other areas that you can dig further. So primarily now, once you identified some issues, then there is in your report or in your discussion with the developer teams, you probably may need to give them guidance in terms of, hey, you know what, I found this issue and this is how you need to fix it. If you're a white hat or a gray hat person, right? If you're a black hat, I don't want to discuss in that area. But if you're working with people whom you want to improve in terms of delivering secure mobile apps, then you need to give a recommendation. This is the vulnerability and this is the fix, and this is how you need to develop securely. So in such cases, we'll cover anyways in later slides how OWASP actually has come up with the testing guide, and everything related to how to fix those issues as well, right? So in this, my main suggestion, if I were talking to a mobile app developer, is that make the mobile app as dumb as possible. That means it should not have sensitive data locally stored on the mobile device. It should do everything, via the back. You call whatever activity that you want to do on the mobile app, you just make a call and get it back, right? But there are more improvised way, instead of just this transaction request response, there are nowadays more better ways of doing it. But all the point here is you should recommend not to do anything sensitive or not to store anything sensitive locally on the mobile app. And everything should be, if it is sensitive, private, and something that shouldn't be revealed, it shouldn't be kept on the mobile app, but it should be retrieved from the backend. Yeah.
Okay, that's great. One second, let's go to the next slide.
Right. So then connecting all that to the threats and defense, this is the same slide we had last time, but this particular link also covers both device and app security layer controls. So as you learn about the app, the foundation of it with the secure coding requirements, then when you read this particular different capabilities that an adversary has, how they are going to attack it, what are the attackers available, and what you can do about it, then you can put all the device and application security line by line, and it will start to make sense that, okay, why people are asking us to do it, right? Why security engineering and other security consultants are behind implementing these controls, because this is a very, I'd say, one of the most important document that I leverage all the time, is to look at what are the capabilities out there where people will attack me, right? And they do a very job of keeping it up to date. So, one other point at the bottom that I mentioned is the mobile threat defense and mobile endpoint detection and response. These are like upcoming areas. The threat defense has been out there, but basically just like on your Windows and Mac, you have endpoint protection. We use this all the time. Mobile endpoint protection includes these two solutions, which is MTD and EDR, and that is evolving space at least in EDR area, because it requires some significant understanding and configuration in order to leverage it to full extent. But something to keep in mind, keep it up to date, and start reading at least about the threat defense is now becoming very popular, and people are rolling that out as an endpoint protection for mobile.
Sure. So this EDR, is that something that an MDN would have? Is it something that mobile OS will have? Is it something that you want to put on your managed devices? So where does that?
Yeah. So this is more for managed devices, because you cannot control the consumer devices, and it's more for managed devices, protecting further apps, because in case of managed devices, you can have corporate owned devices or BYOD, right? So BYOD, you know that there is some other activity going on the personal side, and that is where mobile threat defense procure enterprise area, so that even though something bad happens on the personal side, it will continue to protect the enterprise data and the apps associated with it. So that's where it comes into picture.
And I think this is great, because even if somebody is not interested in a job or a career, and mobile security or anything, even if they are just app developers, then this threats and defense will help them secure their apps. And that's great.
Right, that's correct. So if you look at the policies offered by mobile threat defense, ultimately they are all driven by Apple and Google providing those hooks into their operating system. So as an app developer, in many cases, those hooks will be available to you. So you can leverage that within your app and offer the same protection that they are offering in that product.
Mohan, you wanted to add something?
No, that's fine. I think he covered it well, Mitesh. Thanks. So this is a common slide, that we used in the last session and this one, and it would be there in the next session as well. The reason being, it has covered all the aspects, of mobile ecosystem security. This is kind of a universal slide, I would say, for any, threat and defense task that you have to take it up. It could be web, it could be mobile, but this is primarily for mobile. So yeah, this is, I would say, this covers everything. If you 80 or 90% of what you're doing is covered, or by your application or by whatever. If you're doing MDM or if you're developing mobile app, 80 to 90%, if you're covered with this and your defense and controls are in place, then I would say you're kind of covered.
Right.
Okay, thanks.
So the next, moving on to the testing area, right? As Mohan mentioned that if you're a developer, you're already used to doing the functional testing, QA testing. Now think about it from the security testing, which is basically you had functional requirements, so you did functional testing, and consider the app security that coding best practices as a non-functional requirement, and you have to do the non-functional security testing, right? And if we look into the open source framework, there is basically a couple of them. Frida is becoming very popular and leveraged by most pen testers, at least the manual pen testing area. MobSF, maybe Mohan can add a little bit more there. Mohan, if you have any experience, please go ahead and share.
Yeah, I have used it, MobSF, since last 5+ years, and it's evolving nicely. Ajin Abram, he was the one who started this, a good friend of mine, and he keeps on adding these features. Earlier it was only for static analysis. Nowadays, I think since 8 to 9 months, there's a dynamic assessment feature also has been added in the MobSF framework. And I'm sure, if you start using it, you will start loving it. Actually, I've used it, so that's why, from experience, I'm saying this. Yeah.
All right. And then, if you're in a large enterprise environment, yes, there are commercial tools out there that can provide those capabilities as well. So it's really which environment you are in, what kind of budgets available, etc., that will drive the selection of the security testing frameworks.
Okay.
This is again the same slide that we used last time about the training and certifications, because some of these slides I used as is because I want people to understand that whether you are in device security or app security, these concepts go with it, because you're just essentially foundation. Don't treat them as two independent things. They are actually connected, right? We just, because of the content size, we distribute them across the 2 sessions, but you really need to understand building foundation and all. And so I think we covered this slide last time, and there are basically look for the training classes that your employer provides. I know there are so many YouTube videos out there that you can watch and come up to speed. All the frameworks that we mentioned about the security testing, all that, they have their own documentation where you can leverage those and come up to speed very fast.
Yes. And one thing I just wanted to point out is that even though like now you've gone through this training, intensive work, you've got your first job that you wanted in securing mobile devices, or maybe like, in enterprise kind of environment, it doesn't stop there. So it's not like one and done. It's like every day. That's, I think, where your journey begins, basically making sure that, you stay one step ahead of whatever attacks and threats are going on. So I think that's when you really need to be careful, because every day there will be somebody trying to break into things or trying to, whereas, whatever you learned yesterday was just like that, a point in time.
Sure.
Very true. In fact, I think anyone who's working in the security domain would, echo the same thing, Niloufer. So in security, you have to be constantly learning every day, and the attacks. I mean, in a way, I would say thanks to hackers, because they keep inventing newer ways of getting in, breaking in, in your mobile, in your APIs, in your enterprise network, and we in turn get an avenue to learn and ensure that we understand how the attack works and we know how to fix it then, so it's a continuous process, and that will just go on and on. Yeah.
Okay.
Right.
Okay, so
Mohan, you want to touch on this?
yeah, sure. Now that you got training, you got certification, and probably you would have landed up in a job with mobile AppSec now, or in an area where mobile app is being developed. So how do you get into the actual app security, mobile app security, right? So it's very easy, by the way. The reason why I'm saying it's easy because we have Android ecosystem, which is free. You don't have to pay for anything, and these days everybody has a mobile phone. Most likely it will be Android. In some cases it will be iOS. But if you're going to start in the mobile app security domain, you can, the easiest step I would say is the get into Android application security first. You start testing it, and the setup required for Android application security is very minimal. You can start with emulators, and then you can go ahead with, once you've got enough experience, you can move on to the device-based security testing, right? When it comes to iOS devices, you probably may need a developer license if you're hacking, from the code level. But anyway, you would need at least some investment in the Mac OS device. It could be, iPad, or it could be iPhone, or it could be, MacBook. You're working with the code, you are trying to understand how the code is written. You need a development environment, right, like Xcode, and similarly for Android, right? So in iOS, I would say there are little inhibitions, there in place. But for Android, you can first start with Android, understand how the ecosystem works, how you can actually learn different dimensions of the Android application security ecosystem, and then once you're comfortable, then you move to the iOS. Uh, so imagine that you have the setup ready. I would say one can start with emulators or simulators. You don't need Android or iOS devices to start with. I'm saying, understand how the app works. Once you set it up in the emulator, you can interact with various features, and then you see what data is being or what requests is being sent to the backend, and then you can intercept those requests, and then you see, can fiddle with it, and if there is no incomplete validation at the backend, you can actually exploit that and declare that, hey, there's a vulnerability there. And
I
in some cases, yeah, go ahead.
No, please continue.
Okay, so if you're working on emulator or simulators, there is a limitation, of course, because not every device feature can be simulated or emulated in the software, right? So you need, at some point in time, there would be a need to test on actual devices, right, like Android or iOS devices. So in such cases, in that path, at some point in time, you would feel a need to check if I think Mitesh touched upon it earlier in one of the slides. Rooted devices or jailbroken devices. So rooted is for Android, and jailbroken devices are for iOS ecosystem. So you want to understand, if I root the device, or if I jailbreak the device, and if the app is installed on that device, what all is at stake? What all a hacker can actually see, and then can make use of it to further the attack, right? So further sense, I start with the application layer, and then I go into the API layer, and then I go into the backend, and then eventually the data, right? So you can actually, simulate that, understand that if you install that app on a rooted or jailbroken device. So in certain organizations, if the app is done, they don't care whether it is installed on a rooted or non-rooted or normal device, or jailbroken or normal device, because even if they install it, there's there. Guys, can you hear me?
Yes,
Yes.
we can.
Okay.
Yes, we can.
Yeah. So in certain organizations, the practice is they look for the underlying device where it is going to be installed, a jailbroken or rooted device, and if it is found that uh, it is a jailbroken or rooted device, they basically stop the installation of that app. So the point is, it depends on how far an organization wants to go and install the app, right? And how sensitive the app data that may or may not be, stored on the local on device, or locally on that file system, right? So, so at some point in time, you would need to understand how to root a device, how to jailbreak a device. So you can, take an old iOS or iPhone or Android device and then start trying. So there are. I don't want to point to the links where you can get it, because it's a gray area. But if you search, I'm sure you would get it. So you can find out how to root a device or jailbreak a device, and then you try to install that corporate device or corporate app, or a enterprise app or a consumer app, and see what you can find basically, right? In the if you have a rooted or jailbroken device, you can actually see through the entire file system, right? So there are two areas, one which is like common area, and the another one is where it is meant only for that app. So whatever that you're storing on the app in that file system dedicated for that app, you will not be able to, the other apps will not be able to extract that data. But again, there are loopholes in the OSs, right? Android, iOS earlier had these loopholes, and people were successfully, exploiting those. And then they were able to trade the data, sensitive data stored only meant for that app, into other apps, right? So all those possibilities open up, when you start working with rooted or jailbroken devices. Yeah, maybe we can go to the
So
next slide.
one approach I have seen is
Yeah,
where,
yeah,
as a developer, if you're developing, let's say, an app that has some low risk function, some very like a general information versus some high risk function that requires you to store some information. So what people do is they allow a user to run the app on any device, whether it's jailbroken or not, or rooted or not. But when it comes to high risk functions, they check for the jailbroken rooted devices, and if they find it, then they stop user from further proceeding from that point on. So this way, you're not completely blocking user to use your app, but at the same time, you're not allowing them to take the risk, and more like it's more an informed design where you are educating user and say, hey, your environment is not suitable for this kind of transactions. So that is one approach I have seen.
Sure.
yeah.
And
There
most
are,
MDMs will also have a check that
Yes.
it's not loaded onto a
yeah,
So in an
rooted.
enterprise environment, checking for jailbreak and routing detection is like an absolute minimum requirement. And
true.
the reason for that is that when you get your device for iOS and Android, the app sandbox slide that we looked at, right? You do not have direct access to those. Jailbreak routing opens up access to that sandbox, and that's where all the data is. That's why that control is critical to implement, at least in an enterprise environment. And then in a consumer space, you can take the approach of this risk-based approach, where looking depending on what function they are trying to use, you can check for jailbreak or not. Right. So,
True, true. And just to add, what I've seen in the last decade or so, the the ways in which you detect, or your app detects whether the device is jailbroken or rooted, the variety of techniques have evolved over a period of time, and the moment it matures, there is a way to bypass it. So it's a continuous process, and you have to keep learning newer ways of detecting the jailbroken or rooted devices. But eventually, that will also fail. That means people may find a workaround it, and then your app may not be able to detect that. So you have to keep learning as a developer, as a tester, as a AppSec consultant. You have to keep learning newer ways to protect as well as to bypass, so that you can guide the development teams better. Yeah, yeah. I think the next slide basically talks about where do you get to a point from where you can actually start moving in different areas of mobile AppSec. And I would say the link at the top, oasp.org www-project-mobile security. Now on that page, if you go, you would see these are just few things. There are many more things listed out there. So it basically, I'll just quickly go through it. It talks about a secure testing guide. That means it can be iOS or Android device. It basically tells how do you actually, get into setting up the environment. How do you test a mobile app? So that's a very good document, and I have used it personally. I can vouch for it. Then there is a ASVS, mobile ASVS or mobile application security verification standard. Just like we have for web ASVS, we have it for mobile as well in the OWASP. And that basically tells us, the items that need to be there, when we are ensuring that the app that you are developing is secure, right? So you can actually look at that document as well. And then there are many projects, like OWASP iGoat tool project, which basically intentionally vulnerable iOS app. So developer or tester or whoever wants to get into this domain, they can actually download this app and then play with it and identify various vulnerabilities that are in there. Since this app is intentionally vulnerable, it has a lot of documentation, very beautifully explaining how to detect a particular vulnerability, where you need to go, what you need to do, so that you can, identify those vulnerabilities. So once get used to this, Android or iOS vulnerable apps, intentionally vulnerable apps, you can then move on to try the other normal consumer or enterprise apps, and then see if you can identify through that approach some vulnerabilities in there, right? So yeah, there are other Android CK project is primarily focused towards mobile data privacy and security. Damn Vulnerable iOS application is again another project from OWASP where they're talking about developing newer ways of injecting vulnerabilities into an application so that the newbies actually can learn from it and mature their understanding. MSTG Hacking Playground. This playground has a lot of iOS and Android intentionally vulnerable apps. So you can actually go there. I mean, this is one place where you can get many such apps. So once you're done with say iGoat or damn vulnerable iOS application, you can focus on another application, set of applications, either in the Android domain or in the iOS domain. And then once you got enough experience, then you would know what kind of maturity that you have reached, because there are difficulty levels in these damn vulnerable, intentionally vulnerable apps. This page or this URL also has mobile security checklist. Now, just like I asked in the last session about MDM, once we have all the standards there, now I look at the standard, I implement the MDM, and then there should be a checklist, right, to confirm whether whatever I have done is as per the standard and there is no loophole or missing configuration or incomplete configuration, right? Similarly, mobile security checklist also gives the same confirmation to you. So once you're done with the development or once you are testing a particular mobile app, you can just go through the entire checklist and say, okay, did I test that? And you can just go on checking. And then once you're done with it, you can then summarize, whatever the findings that you have, and then you can share that, with the respective teams.
Sure.
Maybe, yeah, okay. Go to the next slide. Probably this is the last one. So I have learned the basics. Now, what next for me? As a new entrant into this field. So there are multiple ways to do that. Take the next steps. First, I would say is bug bounty platforms. There are many. I don't want to name any, but these bug bounty platforms are really best place to start. Because bug bounty programs. I think in Niloufer we covered one such covering bug bounty platform. In the past, you can have a look at it. So bug bounty platforms are place where the hackers or AppSec consultants want to get into this domain, or they want to show off their capability, right? At the same time, there are customers, bug bounty platform has. So they have their enterprise web applications or enterprise mobile applications or consumer apps, right? So they want to test those before the hackers in the real world can, hack it in the public domain production, right? So they say, okay, hey, bug bounty platform, these are my apps. Can you ask your testers or researchers to hack and give us a list of issues so that we can fix it, and then we can go to production, right? So in the bug bounty platforms, you are legally authorized to break the applications. It could be web, it could be mobile, or it could be anything, right? So you're legally authorized. That means there is no danger of, if you find a vulnerability, you can safely report it, and then you would get a bounty as well, a reward in return, right? So bug bounty platforms is the safest next step, I would say. After you are thorough with your learning all the basics. And one important caution that I want to give is the ethical disclosure. Now, uh, I mean, when I was, what I would suggest is, if you're finding any vulnerability in an app, right? So you should be doing the disclosure of it in a responsive manner. That means you should go to the owner of that app and say that, you know what, I have did some testing and then I found this vulnerability, and this can be fixed in this way, and you give evidence, how you found it, and then you give some time to them, so that they can go back, work with the development teams and confirm whether it's a vulnerability, and then if it is a vulnerability, then they would fix it. And once they fix it, they basically probably give you, some reward or add you in the Hall of Fame, for that organization. But I would strongly advise not to publish such vulnerabilities which you have just found on social media. But the safest is bug bounty platforms. But if you want to go beyond that, ensure that you're doing whatever you're doing it in an ethical manner, so that you go owner submit the vulnerability and give some time for them to fix it. Once they fix it, then you can ask them permission if you can talk about it in the social media and boost about your capabilities. So if they allow, yeah, go ahead and do it. But only when the issue is fixed and the patch or next version is actually released, that time it's the right time to go to social media, and not before that. So ethical disclosure is a very, very important thing. And I have seen, out of being amateur, sometimes the new entrants actually just want to show off in the social media. The moment they find issue, they say, "Hey, Twitter, this is what I found," and that's not fair for people, right? That's not fair for the application owners, because at the end of the day, there are a lot of pieces that work together, and then app goes out in the production, right? So if you want to really help, as showcase your capability, you do it in an ethical manner. You give them some time to fix the app owners, and then once they fix it, they release a new version or a patch. Then you basically ask if you can, put it in the public domain. And then once it is done, obviously you would get all the accolades, appreciation in the social media as well. But I would strongly advise not to do that in the beginning itself, the moment you find it, right? It's not fair on the app owners. Yeah.
Sure. And all of us, we abide by a certain moral code of conduct, professional ethics. So I think, yeah, thanks for pointing that out, because maybe you are not even aware of a law, but if not the right. So next week, we are going to talk about API security, right?
Correct.
That's right.
And can you give us a little teaser on what we'll be covering?
Yeah, just like OWASP has, web risk, top 10 web risk, top 10 mobile risk. OWASP has come up with API top 10 risks as well. So we'll be covering that, and we'll be, if someone is actually a developer, someone is non-developer, if they have to come into the API security domain, what are those, pluses and minuses that are involved? What is the, learning curve that is involved? What are the prerequisites? How they can get started? So those are some of the things we would cover in the next session.
Okay, perfect. That sounds great. Thanks, everyone, and we'll meet next week. Thank you so much. Thanks, Mohan. Thanks, Mitesh.